In a previous video, we learned about callback functions and we also covered a little bit about higher order array methods like map, filter, reduce, etc. In this video, we are going to dive deeper into these array methods and take a look at 4 such higher order array methods for each map, filter, and reduce one by one. So let's just jump right into it. Before I tell you about these inbuilt array methods, let's try to do a quick exercise. We know that arrays are one of the most fundamental data structures in JavaScript. Arrays are frequently used to manage lists of data. One such example is for some student management system. We can use arrays to manage the marks of students. For example, here I have an array of objects called marks. So these objects have this structure. So every object has an ID and it has different properties and values for different subjects and their associated marks. Given this array, what if I ask you to give me a list of all of the students that have scored greater than or equal to 90 in science? So you would probably do something like this. So first of all, you're going to create an array, an empty array that is going to store a list of all of the students that scored greater than 90, greater than or equal to 90 in science. Now, assuming that you don't know about these inbuilt array methods, you're probably going to use a traditional for loop. So your for loop will start from the index 0 and will go till marks.length minus 1. Now you will check for every element in this array. You will check if the marks at this index is greater than or equal to 90. If yes, you'll push this element to this new array, and after the loop finishes, you will now have a list of all of the relevant students here. What if I ask you to find the maximum marks scored in science within this list? So again, you would do something similar. Instead of creating an array, since the final result I want is just the maximum marks, you will still create a traditional for loop. You will check for every element at each index of this array. If marks I.science is greater than max marks, then update max marks to be marks I.science. And after the for loop finishes, you will have the maximum marks stored in max marks. Now, in both of these exercises and the code solutions, we have one thing that remains the same, which is the for loop. The logic inside of this for loop is different. However, the for loop remains the same. So let's try and refactor this code so that you don't have to rewrite this for loop every single time you want to iterate through this array. So I'm going to put this for loop inside of a function. So function loop array accepts a callback function. Then it iterates through the marks array, runs this callback function for each element in this array. Now you can rewrite your previous two solutions using this loop array function like this. So for the first solution where you want to find the students that have scored greater than or equal to 90 in science, this is how your callback function would look like. Inside of the loop array function, you provide the current student or the current element at this index to this callback function. And then inside of this callback function, you simply just check if student.science is greater than or equal to 90. If yes, then you push the student inside of the students above 90 array. Similarly, for the second solution, your callback function would look something like this. Function find max marks. If student.science is greater than max marks, you will update max marks to the current value. Notice how you can reuse this loop array function multiple times and provide different callback functions depending on your requirements. So here, this loop array function accepts a callback function, and we can also call this loop array function as a higher order function. A higher order function is nothing but just a simple function that either accepts a function as an argument or it returns a function from inside of it. So here, since loop array accepts a function, it becomes a higher order function. Now, this was a very simple and custom implementation of an inbuilt method that has already been provided to you by JavaScript. I am talking about the forEach method. So there are different ways to iterate through an array. One such way is using the forEach method. So here you don't have to create your own loop array function. You can just use the forEach method. It provides you a clean and straightforward way to iterate through the elements of an array. It accepts a callback function that it executes on each element of the array. Let's take a look at a custom implementation of the forEach method on arrays. So you can think of this as how this forEach method may be internally implemented. So this is an inbuilt method, which means that you don't need to implement it yourself. Here, I've just provided an example of how the implementation might look like. The actual implementation differs from this one. So I've kept it simple here. Array.prototype.forEach. If you don't know what prototypes are, just ignore it for a second. All it does is it adds this for each method on all array instances so that you can call for each as a method on all arrays in JavaScript. So here I have an array called colors. Instead of calling for each as a function like we were doing with loop array before, now it's not a function, it's a method on this colors array. So you can simply just do colors dot for each and provide it a custom callback function. This for each method is a simple function that accepts a callback function and it just simply loops through this array. Since this is a method and we are not passing the array directly to it, in order to access the array from within this method, we make use of the this keyword. So here, just think of it like this, that the this keyword here refers to the array on which this method is called on. So if it is called like this, colors dot for each. So this here refers to colors, the colors array. So let I equals to 0, I less than this dot length. So it just means colors dot length, I plus plus, call this callback function with the current element at this index, the index, and the array itself. So the callback function that you pass to this for each method can accept 3 arguments. So here is the callback function that I'm passing to this colors array. So I'm not using the third argument here. I am just using the first argument and the second argument, which is the element at that index and the index itself. So here I'm just simply printing color at index. Index is color. So let me walk you through this code. When you call colors.forEach, this for each method runs a loop from the beginning of the array till the end of this array. And for every element, for every index I, it calls this callback function. So for I equals to 0, it calls this callback function with the element at the 0th position, which is red. Then it provides it the index itself, which is 0. So this callback function prints color at index 0 is red. Similarly, for the next iteration, when I becomes 1, it again calls this callback function. So color at index 1 is green and color at index 2 is blue. Let's do another exercise here. So given the previous marks array, now find the maximum score in this array for the science subject using the forEach method. So here now we will do something like this. Marks.forEach, and the callback function checks that the element at this index, at the current index, is greater than the max marks. If yes, then the max marks will be updated to the current element. Otherwise, it will do nothing. And after the loop has ended, we'll eventually get the maximum marks. So this for each method helps you simplify your code so that you don't have to write your own for loops or your own do while loops. Now let's take a look at the map method. The map array method is used to map an original array to a completely new array. Let's take a look at the internal implementation of the map method. Inside of the implementation of the map method, it first creates an empty array and returns this array at the end of this method. Now to populate this array, what it does is inside of the loop, when it calls this callback function, it uses the return value of this callback function to push an element to this array, to this result array. So when you pass a callback function to the map method, you need to return a value from inside of this callback function. Let's take a look at a simple example. So here I have a numbers array, 1, 2, 3. Now I want to map this 1, 2, 3 array to a new array such that every element in this array is doubled in the new array. So this is how our callback function would look like, item, and it just returns twice the item from this callback function. So when this map method executes, it creates an empty array called result. It creates a for loop, and for every element in this array, it calls this callback function. So this callback function that we provided, it returns twice the value of the element it was passed. So this value is then pushed to this result array, and then finally after the loop exits, it returns this result array. So this map method finally returns a new array that has the value 1, 4, 6. So you've mapped each element of this array to the double of itself in the new array. Note that it returns a new array. It does not alter the existing array at all. Let's take a look at a simple exercise. Let's say you have an array of numbers 1, 2, 3, 4. I want you to map this array to a new array such that the new array has square of each of the elements of the original array. So here our callback function would look something like this, item, and it returns item multiplied by item from this callback function. So you can think of this like this. You have a list of ingredients, and for every ingredient in this list, you actually map this ingredient item to the actual ingredient itself. So the initial array was just a list of the items, whereas the final array is the actual items themselves. So you have mapped each element in this checklist to an actual ingredient. Next, let's take a look at the filter method. The filter method is exactly how it sounds like. It is used to filter an array of elements. So you have an array, you can filter these elements inside of this array based on a certain condition and return only those elements that pass this filter. So let's say you have an array of lemon juice and this lemon juice contains some seeds. So you can filter this array such that only lemon juice passes through this filter and everything else other than lemon juice is filtered out. So this is how the filter methods implementation might look like. So again, since it returns an array at the end of this function, it also creates a new array. And instead of mapping every element or instead of pushing every element returned by this callback function, it only pushes those elements that return true from this callback function. So if the return value is true, only then push this element to the result array. So here I have an array called numbers. This is how the callback function that you pass to this filter method should look like. Notice that instead of returning an element, it returns either true or false. So here item modulo 2 equals 0, which is if this element is divisible by 2, then return true, either return false. So only elements that return true for this condition will be pushed to the result array, thus filtering only the even numbers out from this array. Again, this filter method creates a new array and does not alter or modify the original array. Let's take a look at an exercise. So this array contains either lemon juice, seeds, or water. Filter this array so that the final array only contains lemon juice from the original array. This is how the callback function for this exercise would look like. Item triple equals lemon juice. So only when this condition is true, the current element will pass, which is only when lemon juice is triple equals to lemon juice, the current item will be pushed to the third array. One more exercise that you could do here is, given the marks array, filter this array such that only students that have greater than or equal to 90 marks in science are only pushed to the filtered array. Now let's take a look at the final method for this video, which is the reduce method. Unlike the filter and map methods, which return an array from within themselves, the reduce method instead returns a single value instead of an array. So you can think of it like this: given some ingredients used to make lemonade, you reduce this list into one common value, which is the lemonade itself. So you combine all of these elements using some logic and the final result is one single value. Let's take a look at the terminology used with reduce method. So the callback function that you provide to the reduce method is also referred to as a reducer function, and the final value that this reduce method returns is also known as the accumulator. This is how the implementation of the reduce method might look like. This initial value is used to assign a default value to the accumulator. The initial value parameter is optional. If it is present, then initial value is assigned to accumulator. Otherwise, the default value of the accumulator becomes the first element in the array. And also, if the initial value is present, then the iteration starts from the first element. Otherwise, the iteration starts from the second element, because the first element is already used as the value of the accumulator. So the first iteration is skipped. Now again, it iterates through this array and it calls this callback function, and whatever the return value of this callback function is, that value is used to update the value of the accumulator. So the accumulator is called an accumulator because it accumulates all of the elements into one single value. So the reduce method runs this callback function on each element of this array, and whatever processing is done in each of these callback function calls, it returns a value and then updates the value of the accumulator. And then finally, the final value returned by the final callback function call is used to assign a value to accumulator. And finally, the value of accumulator is returned. So a very simple example here. We have an array of numbers 1, 2, 3, 4. Now, an example of reduce here could be to reduce this array of elements into one single value, which is the sum of all of the elements in this array. So this is how the callback function would look like. So this callback function returns accumulator plus the current item, and the initial value provided to it is 0. So the initial value of the accumulator is 0. For every iteration, it accepts the item and the accumulator, and it adds the current item to the accumulator and returns this updated sum. So when it's called for the first time, so for I equals to 0, the accumulator's value is also 0. Then from the first callback function call, 0 plus 1 is 1. Then the accumulator's value is updated to 1. Then we move on to the second iteration. The second iteration also receives the accumulator, which is 1 now. And then it adds the current item, which is 2. So 1 plus 2 is 3. For the third iteration, it returns 3 plus 3, which is 6. For the fourth iteration, it returns 6 plus 4, which is 10. So here's an exercise for you. Can you find the maximum value from this array using the reduce method? Here's how the callback function in this case would look like. It will check if the current item is greater than accumulator. If it's not, then return the accumulator, otherwise return the current item. And the initial value is by default set to the first element in this array. So there you go. We've learned about 4 different higher order array methods, which are frequently used by JavaScript developers. I've provided you lots of exercises on this topic for you to get comfortable with these methods, because these are going to be your best friends while working with arrays. I'll see you guys in the next video.